You want me to present what? By Miss Tamae.Partain from Arcadius, USA in Atlanta. Tamae is the CEI group lead for Arcadius, serving out of the Atlanta. She is a seasoned professional with over 25 years of experience in all aspects of civil engineering. Her experience spans all aspects of program management, construction management, business development, operations, strategic planning, legislative assistance, innovative technology research, implementation, contract administration. She has experience in vast variety of infrastructure projects, including building construction, water treatment plants, dams, reservoirs, railroad, roadways, parks, bridges, pedestrians, traffic, and as well as ITS fiber projects. Her primary focus is with municipal clients and heavy civil highway infrastructure. She handles all phases of the projects from concept through design, environmental, right-of-way acquisition, utility coordination, and construction, and then project completion. She is the vice president of the National Association of Women in Construction Atlanta chapter, as well as a board director. She's also active in ACEC, WTS, Council for Quality Growth, and various city and county organizations. So right now, I'll turn it over. The floor is all yours, Tamae.
Thank you for that warm welcome. I'll go ahead and start sharing here. We good? Everybody can see that? So this presentation basically explains some of the challenges that occur during construction and how they can be avoided with proper planning. It's really vital for projects designed to understand the full picture of what's needed in the process of how building construction actually occurs. Constructability reviews by subject matter experts during the early phases of design can help mitigate delays and change orders. The importance of procurement and specifics in developing bid documents are also very crucial. It's essential that all parties have a full and complete picture and understanding of what is to be built to obtain appropriate pricing with qualified contractors. Included also as part of the discussion is how design and construction should have synergy and rather than be at odds with one another. We'll additionally talk about some ways to increase efficiency and effectiveness through the full project lifecycle to get the best value for your clients. Then I'll also try to talk about some best practices, common pitfalls, and some lessons learned that I've experienced throughout my career. So I don't know if you guys are familiar with MC Escher. He was a Dutch artist. He's most famous for his so-called impossible construction photos, such as Relatively and Waterfall, seen here. As you can see, these drawings, I mean, they're beautiful, the geometry works, the math all works, but as you know, you can't actually build these and function in reality. So this is one of these things that I always say is that there's no such thing as a perfect set of plans. I'm going to repeat that. There's no such thing as a perfect set of plans. That being said, the goal is to be as clear and concise as possible and try to cover as much as you can so that in the end, everybody has a better understanding of what everybody's trying to do. Constructability is really less technical as it is a thought process. So you want to think about things in a holistic nature altogether. So you basically want to take and collaborate with your construction subject matter experts early on. It'll provide insight and ideas that you may not have considered. A lot of times, you know, your construction folks may have current industry practices that you may not be aware of as a designer. There's lessons learned that they can contribute, as well as insight on things, on how they're actually built, not just what's shown on the plans, the process of how you get through that. You want to have a very diverse team. The more different types of subject matter experts that you have, the greater the possibility that you have that you can have a holistic approach to things. The designer can help explain their intent to these subject matter experts, and then they can chime in and collaborate and help with coming up with the best ideas possible. You want to involve your subject matter experts early, especially your construction folks. So when I say early, I mean early. I'm talking at team advisory meetings, public information meetings, and that way they can understand what your intent is and what you're trying to do, and they can help better assist you to make improve your design in terms of constructability. In the early phases, obviously, these construction folks would be operating as more in an observer type role, so they can better understand the public's concerns and those of other stakeholders. You know, what about time? What about safety? What about disruption, impacts to property, things of that nature. So for opportunities, during the planning sessions, they're basically, like I said, in observation mode. And then in the preliminary designs, they can help you with things like lines, your grades, your layout. And then they can also help you maybe have a best fit of the project understanding for field conditions and design. If you're following like a PDP process, they can be involved and help assist with utilities, traffic, geotechnical structures, drainage, right-of-way survey, scheduling, and construction. And then basically post-construction, they're pulling everything together, you know, at a 90% phase, saying, okay, let's compile all the data that we've got for this project, pulling together your lessons learned, and then tweak any procedures, processes, or checklists, so that basically every time you build a project, your teams become stronger and better the more that they interact with each other. So here you want to be intentional with your decisions, and then because sometimes there's unintended consequences of those decisions that you may or may not consider. So again, this is a collaborative cycle. You want to have a shared purpose. You don't want design and construction to be at odds with one another. Design shouldn't just be design and construction be construction, where design just takes something and hands it over to construction and then expect it to be built. You always want to try to look at the whole picture of everything and how all the pieces actually interact with each other. This is a constant, dynamic, and agile process. Things change, and you need to be able to adapt and mitigate all the changes. So here you're basically asking your typical questions, and what I always call the 5 W's. Okay, so who is this going to impact? Your stakeholders, your property owners, your utilities, the environment, the traveling public. What's the end goal here? What's the purpose of what you're actually trying to do? Where is the best place to build what you're trying to build? Should you, for example, should we try to take out the trees? Should we require someone to lose their home, or have to relocate somebody? Should the widening, if it's a widening project, are we going to go to one side or the other? Are we going to widen to both sides, depending on what the circumstances are with that actual site? And then you want to consider when the constructability review should actually occur, depending on the complexity of the project. You may only need 1 or 2 minor constructability reviews. If it's really complex and there's a lot of pieces of the whole, then you want to have more constructability reviews and more interaction with your construction side. You want to look at phasing. You want to consider long lead items. So, your string poles, your bridge beams, these could take months. And depending on your construction seasons, that could impact your time and your costs as well. So I always say ask why. And then I always say ask this question as if you were a 3-year-old. And then when you've answered it, ask it again. And then when you think you've answered that, ask why again. You basically want to try to think, okay, is there anything else that I could have possibly considered, or something else that I didn't think of? And then always do the right thing for the right reason. Because if you look at some things, well, this works for me from a traffic standpoint or from a signal standpoint, but then it may not work for your drainage people. And so you've got to take all of those pieces and look at everything again as a whole, all encompassing. And then lastly, what I always tell everybody is, would you be happy if this work was actually being performed for you personally? So if you think about everything from a personal perspective and a personal nature, then sometimes the answers, it makes it easier for you to come up with the answers to your questions. Again, working all towards common goals and objectives. And again, this is a thought process. It's how to think, not necessarily what to think, or, the specifics of something technical. This is a funny graphic that I like to pop up. What are we trying to achieve? Remember your clients, and then always actively listen to what they want and need. So us as designers, us as construction folks, we may have all these different and great ideas, but, keep the end goal in mind, and what is it that we're actually trying to deliver for our clients. And I'm not going to read all of these, but you can basically look at it. Everybody sees things from a different perspective, but then we all want to keep in mind, what do we actually want to have And sometimes the solution is something that's actually very simple. And then I know me personally, as an engineer, we look at it and we go, and we overcomplicate things. So sometimes the simplest solution is the best solution. So basically what I'm talking about here is designing for the end, designing for, keep the end game in perspective and then work your way backwards. You want to design for the end result. So here are some general constructability best practices. Depending on the complexity of the project, the frequency and level of reviews, the involvement of subject matter experts needs to be determined at the onset of the project. So you basically start at the beginning and you come up with a plan, depending on what type of project you have, as far as what is reasonable level to involve people through this process. And in order to have successful constructability reviews, it requires that type of a systematic and planned review process. And that will also allow you to provide time for proper validation. Positives of a constructability team meeting periodically throughout the design process allows for a good exchange of ideas and allows everybody to see the big picture, so they can see the interaction and they can see, oh, this affects this, or that changes this. If I do this, then I impact somebody else. Everything we do impacts one another, between departments, between engineering lines, or whatever. So that's what I'm talking about, is that you don't want to operate in a silo. If you have access to contractors, that's also sometimes a benefit, because they can see things during design, because they're going to look at it from a contractor's perspective of how he's actually going to build it, right? And then when you have these reviews, you basically want to have some sort of facilitator to make sure that you're keeping the support staff and everybody on track, and that they don't get sideways or off track of what they're actually trying to accomplish. One really useful tool is to have some standard checklists in your toolbox outlining different requirements. So the checklist can ensure that important items are not forgotten, and then they also make an excellent repository to pull in lessons learned from previous projects. Oh, I need to make sure that that doesn't ever happen again. You put it on the checklist, and then that saves somebody else the heartache of having to go through, the pain of whatever mistake it was that you had made on a previous project. Environmental, obviously, this is a huge issue. Can things be avoided by making adjustments or performing some sort of design exception? Right away, minimize, minimize, minimize. Less area is going to equal less cost, less impact to property owners, and it also allows for easier project implementation. Again, if you can squish some things in or change a layout slightly to try to adjust that right of way to minimize it, you always want to try to do that. Utilities. These are always a little bit of a bear, and I apologize if if there are any utility people in the room, but you have to be really cognizant of the utilities, especially if you've got railroad requirements. If any of you have dealt with railroad permitting, you know how long and cumbersome that can possibly be. You want to keep things in mind, like, are we going to have to de-energize any lines? Do I have any double fed lines? Looking at things like, am I going to affect gas in the winter, electricity in the summer? What are the typical relocation efforts of the companies in your area? Because they do vary from area to area. And then we also know that some utilities are more responsive than others. So you've got to think about the impacts of the seasons, hurricane seasons in the south, snowstorms in the north. For example, if you've got a major power relocation that's got to go in your project, and then it's during hurricane season, there's a very real possibility that all those crews may get pulled for an emergency and may stall your project. Again, nothing that you have control over, but just something you kind of want to keep in the back of your mind when you're designing the project, especially when you're allocating time and trying to figure out what's an appropriate time frame to perform the construction. Are you hanging anything on the bridge? You got to take all of that into consideration as well. How are those tie-ins going to work? Am I pulling services down? Again, that could tie into whether or not something's being double fed or not. Obviously, safety is paramount. Not only safety of the workers during construction, but safety of the traveling public while the construction is actually occurring. This ties into traffic control. You're going to want to think about the logistics during constructions, lane closures, accesses to businesses, schools, residents, life safety. Am I going to be impacting where fire and police can't get through here if there's some sort of an emergency? If there's a school, would it be better for me to time this construction? Maybe that it's during, I'm going to end up adding a turn lane into the school. Well, might be better if you can, and if it's possible, to try to phase that construction so that it's during the summertime, so you're not impacting, school traffic coming in and out, and then that also ties back into safety as well. You want to look at types of construction, precast versus cast in place. Are there any kind of accelerated items that you want to consider? Types of walls, are we doing in MSE wall? Are we doing soil nail wall? Depending on the types of walls you're putting in, that impacts the constructability of how things actually function and tie into your areas. You want to consider your staging. Is there room for the storage of these materials that you've got? Is there room for all the phases? Especially if you've got phase construction. A lot of people think, oh, well, I've got this one staging area that I've popped over here on the plans and it's going to cover everything. But a lot of times people forget that, you know, when you go to stage things and I'm over here, it's not practical to have a staging area on this side if I'm over on this side actually constructing the project. For earthwork, you want to look at, you know, cut and fill quantities. Will the hauling have an impact on the traffic control and lane closures? If you've got lots of trucks coming in and out, you're going to have to consider that as well. Will storage be necessary for the stockpile of the cut sections before they get placed in fill sections? And then as a sidebar, you kind of want to take that into consideration as well, because if the contractor is going to actually have to move the dirt more than one time, you're going to need to consider that when you do your estimates for your grading complete cost. And lastly, like I kind of mentioned before, you know, you want to document as you go for ease of incorporation, any lessons learned for a repository later so that you basically don't make the same mistake twice. So this is a nifty little chart. Basically what it says is that the earlier you start thinking about construction, the greater the impact it will have. The early involvement of construction will save you and your clients time and money. Construction may see something early on, and then you can adjust your design, and then it will save you rework and redesign instead of waiting until you're at 90% plans, have a constructability review, and then somebody looks at it and goes, oh, that's not going to work, and show you something, and then you've got to go back and, you know, redesign from scratch. Where if it was caught at 30%, you know, you wouldn't have been that far along in design. It could have been something that you could have resolved early on. So a little bit of time and money, pulling these folks in, will save money on the front end and save time. And then it will more than pay for itself. And as a designer and a project manager, if you're looking at this from a budget perspective, you know, just budget a few extra hours to have all of this taken care of. Again, I guarantee it will more than pay for itself. So here's some things to ask prior to bidding. So are the plans complete? Are all the sections corresponding accordingly? Have all the impacts been considered? Will this project impact any others? Have we accounted for all the pay items and types? And are all the quantities accurate? Again, can it be built as shown? So regarding contracts and procurement, this is a little bit of an anomaly. Again, it's kind of a specialized sort of field that even design and or construction don't actually take into consideration, but it's very important to your project. So for bid documents, they need to be clear and specific. When you're writing your specifications, especially your special provisions, it requires a little bit of a different mindset. So you've been in the project, you've been designing it, you're down in the weeds of it, but the person that's bidding this and the person that's actually going to build it doesn't have all this access to all this information that's in the back of your brain. So you basically, what I tell people is I try to, when I write these, I try to explain it in a way that my 9-year-old daughter can understand. They need to be written in a way to convey your information and convey your intent to somebody who's completely unfamiliar with the project so they can understand what you're trying to do. It can't be ambiguous in any sort of way. If you do this, it will ensure that you get better pricing on the back end because the contractors will be clear on actually what they're bidding. And I'm not saying that all contractors are like this, but it will also prevent the contractor from potentially taking advantage of something that was ambiguous or vague. So that way you can be certain that, you know, that low bidder isn't going to try to put in a change order late for something that you may not have necessarily been very specific or clear about. So for the bid documents, you want to take, again, look at everything as a whole. A lot of local entities I know will use like a state DOT spec. So and that's great because, you know, it gives you, who wants to reinvent the wheel and nobody wants to rewrite a spec when it's not necessary. However, if you're using a DOT spec, you've got to take your local conditions and make sure that those are incorporated as well, because you've got to overwrite those specs specific to that entity. Sometimes what seems to be simple notes on plans may seem really clear, but to you, but it may not be clear to other people. For example, somebody may put down, oh, that I want black strain poles. Well, are these painted? Are these powder coated? Again, those will affect your pricing and affect the timing of your construction. Who's responsible for permitting? Who's paying for the permits? Who's actually applying? Which entities are applying? How long is the turnaround for the review of these permits? You need to outline all of these requirements in your bid documents so that the contractors, again, know what they're bidding on and know what's expected of them. And then I always try to recommend, if at all possible, to have someone basically do what I call a final blind review, if you've got resources available. This is somebody who's not ever looked at the project, has no idea what's going on, just take and kind of glance at it and see if there are any major glaring errors with anything regarding all of that. So here's a quick example of a project regarding bidding. So there was basically, as part of the design, they decided that they were going to reuse part of the structure as part of the new design. So basically, the replacement of the bridge required the bridges to be replaced in essentially the same footprint as the original bridge. And as part of the design, as is noted in the figures in the plans and in the special provisions, the designer determined that the new foundation would be able to utilize some of the existing H piles. But as I'm about to show, the bid plans and specifications appear to be very clear, but in the end, there were some ambiguities that people didn't consider. So again, here, we've actually got 2 stages. They're basically outlining the same stages. You are going to reuse these. You need to inspect it. You as the contractor need to make sure everything's like it's supposed to be. Again, clear. The existing piles are to be reused. You are not to damage these in any way. You are supposed to take any necessary precautions, etc. Special provisions. Again, you think they're beating a dead horse here. They've gone through everything. They're telling you that you as a contractor have to take and are responsible for all of these items. But in hindsight, and after this project actually went to construction, there were some problems. So during the initial baseline schedule development, the contractor said, well, we assumed that the designer was going to do a 3-day review period. Well, that's not realistic. But that being said, they didn't say what the requirements were of that. So the department tried to argue that engineering reviews are standard 30 days. But then the contractor came back and argued, well, then you should have specified that you were going to take 30 days. I thought you were only going to take 3. Specific to this example, they agreed to 7 days, and they moved forward. During the actual performance of the work, bearing in mind, none of us have X-ray vision and can see what's under the ground. But however, anytime you're doing something, especially if it's something underground that you can't see, you basically kind of want to say, okay, well, let's assume the longest time frame in the worst case scenario. So during the actual performance of this work, contractor did the initial cleaning and the prep is called for, pulled everything out, and then it turned out once they pulled everything out, there is an apparent section loss at the top of the pile. So then the engineer had to go back and look at that, and then that took even longer than the original 7 days that they'd agreed upon. Then they had to go back and forth to try to figure out, and then there was change orders, and everybody was confused. I mean, ultimately, after extended a period of time and further geotechnical analysis, the engineer, had to scamper to try to come up with an acceptable repair procedure to try to figure out how to move the project forward. Unfortunately, all this back and forth costs the project in excess of 200 calendar days. When you go 200 calendar days, it also affects your construction season. So in the meantime, this is an interstate bridge. So you've delayed, again, interstate. Think about the impacts. You've got people calling. People do not like to be stuck in traffic. People do not like, to be inconvenienced by construction. So, and then this is only on phase 1. So most likely there's a high probability that you could have this situation on phase 2. So again, construction is messy and things are going to happen and you're not going to be able to predict everything. But, always try to consider the worst case scenario. And then if that doesn't happen, then you can over deliver on what you're promising on. Again, if you involve your subject matter experts earlier, if I had seen this early on, I would have said, "Ooh, I don't know that you can do all of this, and you may want to have some contingency plans already in place for how to handle all of this." So again, by not having constructability reviews, your cost and time is going to go up. And in the meantime, your reputation is going to go down because your client may say, "Well, why didn't you consider that?" And again, none of us have a crystal ball and know exactly what's going to happen. But if you try to think about things, again, in a holistic type approach, it can save you in the end.
All right.
So now you've got your bids in. You're looking to see if it's balanced. You want to look and see if it's aligned with your engineer's estimate. You want to look and see if the bids are aligned with each other, or are there any other weird sort of abnormalities. A couple of things I try to look for. These are very simple. Look for items priced at like a penny or $1, because sometimes the contractor will look at those and say, "Oh, something's a little bit off here." You also want to look at any of your unit price to see if they're way above or below industry pricing, and look at your lump sum items to see if they may have taken some portion of another part and then basically not unbalanced it, but maybe skewed it to some extent to try to make sure that they got their money. And then if you do see something that's really off, you may want to get with your clients and say, "Okay, something's off here. We may want to consider either looking at this again or rebidding it." Nobody wants to rebid it if they don't have to. However, you don't want to go into construction knowing that there may be a huge change order looming in the end.
Okay, well, Tamae, I don't want to cut you off, but I think I gotta save time for our second presenter as well. I know it's tight, a lot of good information that you're presenting, and I appreciate it. There's no questions yet, so I just want to remind everybody if they want to post questions to the speakers Q&A tab. We have Rich Ames, Senior Project Manager from WSP Monitoring, and will be facilitating any question and answers coming out. So with that, I want to turn it over to Greg Soule for his presentation on a modern truss for the 21st century, the Pond Eddy Bridge Replacement. Greg is the office manager and the senior project manager for SAI Consulting out of Lemoyne, PA. He has over 23 years of experience in transportation industry. He's a Penn State grad from 1997. He has extensive experience as a highway engineer and project manager on the Pennsylvania Turnpike Commission and PennDOT agreements. He also oversees business development for SAI in central and eastern Pennsylvania. Greg is a member of ASHE Clearfield, ASHE Williamsport, and the ASHE Northeast Penn chapters. And he currently serves as board of directors for ASHE Harrisburg. Greg, presentation's yours.
All right, thank you very much. I'm having a little trouble sharing my screen here. Whoa. Not sure. I apologize. Oh, there we go. Everyone see that now? There we go. All right, so this is the Pond Eddy Bridge Replacement Project. My name is Greg Soule. I work for SAI Consulting Engineers. This project is located in Northeast PA on the Pennsylvania-New York border, and the bridge crosses the Delaware River. We are just north of Interstate 84. The project site, New York 97, runs along the left side of the river. There are two intersecting roads, High Road and Hollow Road, on the New York side. And then we have, on the Pennsylvania side of the river, we have two dirt roads, unimproved, and the Norfolk Southern Railroad. So the Pond Eddy Bridge connects Shohola Township, Pike County, and Lumberland, New York. The site is located within the Delaware Scenic and Recreational River National Park. What's unique about this site is that the bridge serves as the only access over the Delaware River to the community of Pond Eddy. The community is actually landlocked in Pennsylvania. It's surrounded by Pennsylvania game lands. The ADT on the bridge is only 30 vehicles a day. However, the boating traffic through the bridge during the summer peak season can be in the hundreds or even thousands. So this is a picture of the existing Pond Eddy Bridge looking downstream. And a picture looking at the deck. There are wood slats over here. The bridge was built in 1904 and 1905. It's a single lane, two-span, pin-connected Pennsylvania through truss. The existing structure throughout design was rated as poor, with weight postings as low as 3 tons. What this really meant is that the residents of Pond Eddy could not be accessed by emergency vehicles, and they couldn't get things, delivery trucks in for things such as oil, coal, propane, those types of necessities. So in 1993, long time ago, PennDOT began an 18-year study of alternatives with consulting parties, the public and stakeholders. They looked at a number of alternatives. We looked at no build, off-site avoidance. Could we bring in a new road through the game lands to access those properties? Rehabilitation of the existing structure and full replacement. We even looked at one point at could we purchase the properties on the Pennsylvania side, but that ran into some major legal hurdles, so we had to abandon that immediately. In 2011, a memorandum of agreement was signed to replace the bridge with a number of conditions. One, we had to do historical recordation of the bridge. We had to market the reuse of the existing bridge. We did have a couple inquiries about the bridge at the time, but due to the deteriorated condition, we really had no takers. We formed the Pond Eddy Design Advisory Committee, or DAC, which included all of the agencies, including National Park Service, historic preservation groups, municipalities, community, anyone who had an interest in the bridge. And we also agreed to archaeological monitoring during construction. I'll cover that a little bit later. From 2011 to 2013, the DAC met 4 times and ultimately decided on an offline 2-span truss replacement structure with no alternatives. They decided on everything from the configuration to the size of the bridge, to the color, to the architectural treatment, all the way down to the stone pattern and the relief and the color of the stone staining that we did, or the concrete staining. In July of 2013, the CE was signed after 20 years, and we started final design in November of 2013. So what were our hurdles on this project? We had a number of environmental concerns. We were located within the national park, as I mentioned. There's a federal and wild scenic river and a PA water trail. We had shad and eel in the river, and we had to account for their migration and passage during construction. We had bald eagle nesting sites, and we also had freshwater mussels. So with all those environmental concerns, we had our hands full obtaining the permits for this one. We were dealing with the Army Corps, National Park Service, Delaware River Basin Commission, PADEP, New York DEC, Conservation District, U.S. Fish and Wildlife, Upper Delaware Council, and Fish and Boat Commission. It was a struggle at times, but we managed to get our permits with some interesting requirements. We had to relocate over 3,000 freshwater mussels to another site on the river. We had noise restrictions. We couldn't do any demolition or pile driving from certain dates and at certain times. We actually had to design the causeway to accommodate the burst speed of a shad to allow migration upstream during construction. We couldn't have excessive velocities. We had to do pre and post construction survey of the stream banks and stream bed. And we had to have a hardline phone operational on the causeway for any boaters who ran into emergencies. There's no cell service, so they wanted to make sure they had that available. And they also had to keep a rescue boat on site at all times. I don't think that ever got used during construction, fortunately. So our constructability issues were many. We had no construction access through PA. As I mentioned, it's a landlocked community. There was a railroad. We met with them a number of times to see if we could get delivery of materials and equipment with the railroad, but we had to work around their schedule too much, and it just wasn't reliable enough for the contractors. The existing bridge was posted for anywhere between 3 tons and 7 tons at time, which meant the contractor couldn't bring his equipment and materials over the existing bridge. And the National Park Service had a requirement that we had to maintain boating traffic at all times. Normally, we would put in some temporary bridges. We looked at long span bridges for boater passage, but the National Park Service said that was a safety concern because of high water conditions and the possibility of canoes and kayakers getting stuck under when they were trying to, quote, ride the rapids. We looked at short span removable bridges at a November 2014 VACT meeting with contractors, but the contractors indicated that they were much too restrictive based on the time that it takes to install and remove those bridges. So even though it was acceptable to the Park Service, we had to rule that out. So what we agreed to at that VACT meeting was that they wanted to see a half-width causeway constructed in the New York Channel. And then once the New York span of the truss was completed, they would relocate the rock directly from the New York Channel to the PA Channel and build a ramp from the end of the new truss down to the Pennsylvania Causeway to allow for delivery of additional materials and equipment, and to be able to get their equipment out of the river during high flows. We had to design the causeway to allow the contractor to work 90% of all calendar days. We were trying to maintain 150-foot minimum channel opening for the boaters. And we had to do the H&H analysis to accommodate a 5-year storm event within the 100-year floodplain. So the results of all that are in the pictures to follow. We started in August 2016 with an entrance ramp to the causeway along New York 97. And then we essentially put a football field of rock, R8 and R3, into the New York Channel. You can see the contractor with all of his equipment and materials stored on that causeway. We did design the causeway to overtop. We made sure that occurred. We had about a half a dozen incidents of overtopping in the 2-year project, during 2 years of construction. And then this is a picture of the ramp that was built from the end of the New York truss down to the Pennsylvania Causeway. It was about 30 feet of R8 and R3 rock to build this. We actually installed railroad ties against the architectural treatment of the pier to prevent any damage from that. So this is a picture of the completed ramp in Pennsylvania Causeway. This is looking down from the top of the ramp. It was constructed at about a 12% grade, which was acceptable to the contractor. And then the contractor, we also designed a exit strategy for the contractor on the Pennsylvania side. This also included a platform, as you can see, with for some staging and storage of materials and equipment for the contractor, since we were very limited in area on the Pennsylvania side. So some other things we did with the design, we had continuous public outreach. We had newsletters that were sent to the community and the municipalities. We maintained a website for the project so people could get regular updates. We had a meeting, actually several meetings, with the rafting, canoeing, and boating businesses that were up there. They were extremely concerned about what this was going to do to their local businesses. They weighed in on the 9-stage ATON plan that we came up with for the project. And we also held a public meeting in January of 2016 to update everyone, including the DAC, on the design progress, the schedule and sequence of construction, and present a 3D bridge model. So we worked with PennDOT's central office. They had actually just acquired a new 3D printer, and we actually printed the Pond Eddy Bridge, the new bridge. And this model was taken to the public meeting. It was a huge success. And if you get a chance to go up to District 4 in their office once COVID restrictions end, you'll be able to see this model in their lobby. So I mentioned the archaeological monitor. New York 97 was constructed on top of the Delaware and Hudson Canal. We agreed to keep an archaeological monitor on site during all construction activities in New York. That monitor had the authority to stop construction upon discovery of anything to do with the canal, from artifacts and features to human remains. Fortunately, we did not find anything on the human remains side. We did have some stoppages in September 2016 and August 2018 when we uncovered a few sections of the wall, of the stacked stone wall. So here are a couple of pictures of what that looked like. All of this information was documented, photographed, and construction continued right from there. I'm a highway guy, but I'll go a little bit into the structure design. This is a 506-foot, 2-span steel Pratt truss bridge. It's a mouthful, constructed immediately upstream. The Pennsylvania abutment was drilled caissons, and the foundation of the pier and New York abutment were steel H-piles. The truss member size, shape, and configuration was designed to mimic the existing structure per the DAC requirements, while also meeting current design standards. We had many redundant members in the design. You know, in light of what's happening, what happened with the truss in Tennessee, I think, you know, that is obviously warranted. And we also did erection analysis. How was this going to be built on the causeway on site? The typical section is a 15-foot 8-inch travel lane. Yes, it's a 500-foot 1-lane bridge with a 5-foot sidewalk and a 10-inch bridge barrier, about 10,000 square feet of deck area. By the numbers, we had about 1.3 million pounds of steel, 8,000 shear connectors, 2,500 feet of piles, more than 30,000 cubic yards of R8 and R3 rock that we placed in the Delaware River. And we included more than 2,000 plantings that were used to restore the stream banks following construction. Some other unique features of Pond Eddy, we used a proprietary dewatering system. We could not use traditional pumped water filter bags. So we used a truck-mounted trailer that had baffles to clean the water that was pumped. We had a spill containment berm that actually allowed us to refuel equipment on the causeway. We did temporary and permanent relocation of a USGS stream gauge. We added a National Park Service water quality monitor to the pier. We'd had a bioretention area in New York. We included an interpretive panel that was installed adjacent to the sidewalk to document the history of the bridge. And we included vibration monitoring on the existing stone masonry piers and abutments. There was concern that the pile driving and some of the work that we were going to need to do during construction was going to cause stability issues with the pier and abutments. Turns out that engineers and contractors who built bridges in 1904 and 1905 had it together, and we didn't encounter a single problem with that along the way. So in April of 2016, with a bid of $17.2 million, D.A. Collins from New York was awarded the contract. The fabricator was Casco Bay Steel Structures from Maine, and he got notice to proceed in June 2016. So with that, I'm going to take you through a bunch of pictures for construction. Since we're somewhat limited on time, I'm going to fire through these pretty quick. But we were fortunate, SAI was on board for construction services. We attended bi-weekly construction meetings with the contractor and PennDOT throughout the life of construction, and we learned a tremendous amount from being there on site so regularly. So in October 2016, this was the construction of the New York abutment. The shoring was installed and excavation was complete, and removal of part of the existing masonry abutment was complete. They completed pile driving in November 2016 and placed the foundation, the rebar, in December of 2016. And by April, we had a completed New York abutment. At the same time, they were working on the pier. You can see here, there was no winter shutdown. They were fortunate to actually use the ice here as a platform for the one worker. You can see a test pile that was driven prior to the ice coming in there. This is the pier in April of 2017 with the piles started. Forming was done also in April of 2017, and by July we had a finished pier. Erection of the truss started shortly thereafter in July. This is the New York span. As I said, it was stick built. The contractor put together some temporary bents. They were pretty beefy, very sturdy, that they used for construction, 4 of them. And then they continued the stick construction from there. And by August of 2017, we had a completed New York truss. So we had some nice pictures of that. This will give you an idea. This picture gives you an idea of what the new truss and the old truss looked like standing side by side. Very similar shape, but obviously a lot beefier and sturdier than the old bridge. So between August and December 2017, that was when the causeway was moved from the New York channel to the Pennsylvania channel. And then the Pennsylvania abutment construction started immediately thereafter. They were drilling caissons in March of 2018. The rebar cages were in June of 2018. And we had a finished abutment in that same month. They ended up pouring and doing the wing wall work a little bit later so that they could get the truss moving a little quicker. So in June of 2018, they were working on the truss erection on the Pennsylvania side. They used the same temporary bents that they had used on the New York side. By July 2018, we had the truss was essentially put together. And again, this is a picture showing the new truss directly adjacent to the old Pond Eddy Bridge. The deck was poured in August of 2018, and then through some finish work, they finished the bridge in October of 2018 and opened the bridge to traffic. And they didn't waste any time. Immediately afterwards, they started demo of the old bridge. This was the most simple demolition you could possibly imagine. They attached a chain to one of the top members of the truss and attached the other end to a bulldozer that was sitting on the road. And they brought in this piece of equipment with a steel cutter and basically a quick snip and a pull by the chain on the chain, and the bridge came down in a matter of seconds, just adjacent to the Pennsylvania Causeway. So we had worked out with the permitting agencies to make sure that this was acceptable. They were okay with it as long as we put a provision in the contract to have the truss members and any debris removed within 48 hours of dropping it in the river. So we finished that up, and they immediately built a small platform on the Pennsylvania Channel and did demo of that, and the bridge portion was done. Some other things that happened during the life of the project. SAI was on board to do bridge inspection of the existing bridge, and the contractor was under contract to complete any repairs that were needed during construction, so that PennDOT did not have to bring out separate crews to maintain the bridge. In the bottom left-hand corner is the Pond Eddy Bridge interpretive panel. This commemorated all of the old structures and all of the history of the bridge that was required by the DAC. In the upper right-hand corner, we did have one incident during construction. One of the construction vehicles, was coming down a hill in New York and lost control, lost brakes, and ended up having to cross the existing Pond Eddy Bridge before coming to a finish on its side there. It damaged a number of stringers and the wooden deck during construction, and we had to make those repairs in an emergency fashion. And then the bottom right, there was a small restaurant that was located next to the PennDOT office, and they asked if they could put up a sign on the causeway for boaters and rafters to use a staircase that they had installed to grab some cold refreshments as they were rafting on the river. So the contractor accommodated them. So with that, a couple finished pictures of the Pond Eddy Bridge. Like I said, it's fully open to traffic. The old bridge has been removed, and the site has been restored to its as much to its original conditions as possible. So.
Okay, great. Thanks, Greg.
I just wanted to, one last thing. I just wanted to thank our team, the New York State DOT, FHWA, PennDOT District 4, especially the project manager, Sue Williams, our design team, Skelly and Loy, McCormick, Taylor, Navarro, Dawood, and IES, and the contractor, DA Collins. So thanks.
All right. Rich, I don't think there was any questions. We're pretty much out of time to get back into getting ready for the next session.
Yeah, no questions, well, Jay. But Greg, thank you very much for the presentation.
No problem.